Fusion energy is potentially a game changer if scientists can ever actually master the process, and should they get to grips with it, it could signal the end of fossil fuel reliance for good. However, we are still in the early stages of understanding, but hopefully in the future, fusion energy will be a big player in the energy field. Today we are discussing how fusion energy works, so don't go anywhere. First up, what exactly is it? Let's see. Over the years, there have been hundreds of different theories surrounding what exactly the sun is, from the Aztecs' belief that it was powered by the blood of human sacrifice to the ancient Greeks, who believed the sun traveled across the sky in a flaming chariot pulled by 4 fiery winged horses. Of course, we now know exactly what the sun is and how it works, and behind the process is nuclear fusion. If the process could be repeated here on Earth, it would give us access to safe, clean energy, which would satisfy the world's demand for energy. Nuclear fusion is the scientific process which sees 2 light atomic nuclei fuse to form a single, heavier one, which allows for a huge amount of energy to be released. The process all takes place in a state called plasma, a state of matter made up of positive ions, which is a state all on its own, independent of a solid, liquid, or gas. Where the sun is involved, nuclei collide at insane temperatures, somewhere north of 10 million degrees, which allows them to overcome their mutual electrical repulsion. Once this is achieved, the nuclear force between them will overcome the electrical repulsion, allowing both nuclei to fuse together. All this can only take place if the nuclei are very close together, which increases the chance of collision, and as such, fusion. And it just so happens that the sun, with its immense pressure, creates the perfect conditions for fusion to occur. So how can we achieve fusion here on Earth? Stay tuned to find out. Well, first things first, we need to build a fusion power plant which is capable of achieving, and more importantly, withstanding incredible temperatures and pressure. The process has been described as one of the trickiest engineering challenges in human history, as we need to figure out a way to heat up the fuel to around 100 million degrees, which is of course hotter than the sun that powers our solar system, which we're sure you will agree is pretty darn hot. This process will create a fully ionized gas plasma, which will then be lit to create fusion. And as we speak, there are 2 methods for achieving the feat: inertial and magnetic confinement. Inertial confinement consists of ion or laser beams compressing a small deuterium-tritium fuel pellet to extremely high densities. The pellet is then ignited using shockwave heating, which would occur several times a second, resulting in the heat which has been generated used to generate steam, which then powers electricity-generating turbines. Conversely, magnetic confinement uses electromagnets to try and achieve fusion, but containing the plasma fuel. And one option out there, known as the tokamak device, contains plasma in a donut-shaped chamber. A current is then sent through the plasma, which is heated by other systems such as microwaves and radio waves, allowing temperatures of several hundred million degrees. What do you guys know about nuclear fusion? Let us know below. And what are the advantages of fusion then? Well, as we mentioned, sourcing a clean, powerful energy source will be an absolute game changer for the planet, and as such, scientists are hard at work trying to develop nuclear fusion. As we know, fusing atoms together allows for almost 4 million times more energy than more traditional processes such as burning oil or gas can bring, which gives us the potential to power our cities and transport infrastructure indefinitely. Of course, this means a win for sustainability, as fusion fuels are almost inexhaustible and don't pollute the Earth. The lack of CO2 being released into the atmosphere is, of course, much better for the future of the planet, as the only real byproduct of nuclear fusion is helium, which does not contain harmful gases. And of course, some people will worry when the word nuclear is mentioned, but there is no radioactive waste produced by nuclear fusion, and the components can even be reused within 100 years, which is pretty great. This also means that there is no chance of fusion reactors being used to produce nuclear weapons, as there are no enhanced materials. There is also no chance of a nuclear meltdown like we saw in Fukushima, as any disruption would instantly see the plasma cooling within seconds, and the cost is also thought to be less expensive over time. All of this means that if nuclear fusion were to be achieved, it would be a huge step forward for mankind. Are there any disadvantages? Stay with us to find out. Well, the biggest disadvantage is quite simply the difficulty behind the whole process. Scientists still haven't fully figured out how to achieve nuclear fusion by replicating incredibly high temperatures. Of course, it's not exactly straightforward to somehow simulate the effects of the sun, and the only time scientists have figured out how to successfully fuse together 2 atomic nuclei was to the extreme detriment of 2 Japanese cities. There is also the billions of dollars worth of equipment which has so far been pumped into the technology, technology, with limited results so far. Where nuclear fusion is concerned, failure is much more the norm than success, and there have been decades worth of wasted money. Some people have claimed that the money spent on nuclear fusion could have been pumped into more realistic energy sources, while others have questioned whether or not the process is even achievable. As of right now, there is still very little understood about nuclear fusion, so more investigation and brainpower is needed if we are to finally crack the problem. But it seems as though nuclear fusion is still quite a way off. What do you guys make of all this? Do you think it is worth pursuing? Next up, a breakthrough? Earlier this year, scientists at the UK-based JET laboratory announced they had made a huge breakthrough in their quest to crack nuclear fusion. They beat their own world record for the amount of energy extracted by squeezing together two forms of hydrogen. The experiment, performed by a team of European scientists, produced 59 megajoules of energy over 5 seconds, equivalent to 11 megawatts of power. This is more than double what scientists produced back in 1997, but that was 25 years ago, which some critics have claimed is too slow, progress-wise. 11 megawatts of energy is only enough to boil around 60 kettles of water. However, the excitement has built as it validates the design of the model used, the same one currently under construction in France. And Dr. Joe Milnes, who works as head of ops at the lab, said, "The JET experiments put us a step closer to fusion power. We've demonstrated that we can create a mini star inside of our machine and hold it there for 5 seconds and get high performance, which really takes us into a new realm." Of course, this is all pretty exciting for the team, as well as for the future of nuclear fusion, which has been tagged as the last step in proving the tech can be a reliable global energy provider going forward. And one scientist who worked on the project hailed the successful experiment as down to the brilliance of people and their trust in the scientific endeavor. And finally, Jeff Bezos has backed the Brits in their quest for fusion. Amazon chief Jeff Bezos has thrown a huge bone to British scientists, pumping $300 million into the industry via General Fusion, a Canadian private firm which he will invest in. The company announced last year that they will build a new facility at the Culham Centre for Fusion Energy in the UK. The company will test its magnetized target fusion in hopes that it will produce a breakthrough in fusion processes used in stars. And Bezos has decided to plow his money into the Culham Centre because of England's nuclear physicists being hailed as the best in the world. And fusion expert Richard Dinnan said, "If you want to build a fusion power station or reactor and you want to find the best talent pool, it would be in England. This is because the Culham Centre for Fusion Energy is where all the European scientists working on ITER, the International Thermonuclear Experimental Reactor, are." He went on to explain that Bezos isn't investing to give the Brits a pat on the back, but because their scientists are the best and most advanced at nuclear fusion. However, some critics have claimed that he is only investing in the hopes of taking the credit if nuclear fusion is actually achieved at the center, which echoes some concerns over the billionaire space race, private companies taking private citizens into space for a huge price. What do you guys make of all this? Let us know below. As always, thanks for joining today, and remember to join us next time for some more fun and games. Also, why not do us a solid by liking and sharing today's video, as well as subscribing to our channel so you don't miss out on more great content in the future.